Now that you've had an introduction to matrices, it's time to start using those, so let's learn some operations with matrices. First of all, you need to know about the size of a matrix. Well, in this particular matrix, the subscripts tell you what row and column they are in. Rows, remember, go horizontally, and columns go vertically. Whenever you look at this subscript, the first number tells you the row that it's in, and the second number tells you the column that it's in. So this means the element in row 1, column 1. The element in row 1, column 2. The element in row 2, column 1, etc. So the letter M stands for the number of rows, and the letter N stands for the number of columns. So this particular matrix would be an M by N matrix. You always say the size of a matrix by saying the number of rows, and then by, and then the number of columns. You have equal matrices if their size and their corresponding entries are equal. For example, this particular one, it has 2 rows and 1 column. This one has 2 rows and 1 column. So now you have to make sure that corresponding elements are the same. 0.5 is the same thing as 1/2, and 0.25 is the same thing as 1/4. So these two matrices are equal. So let's determine the values of x, y, and z so that these matrices are equal to each other. If you look at the first one, x has to be equal to 1, so we already know x. Then we know 2 must be equal to y plus 1, which means if we subtract 1, y must be equal to 1. This one tells us that 3 is equal to 3. That doesn't help us at all. But then we have z plus 1 must be equal to 2z minus 1. And then we solve. I think I will subtract 2z and then subtract 1. There we go. So we get z minus 2z and negative 1 minus 1. So z is equal to a positive 2. So we have now found x, y, and z so that these matrices are equal. If you want to add matrices or subtract matrices, all you have to do is first of all make sure they're the same size. If they are the same size, you just add or subtract corresponding elements. If they're not the same size, then that operation is just undefined. Okay, so this one tells us to do a plus b. We want to add this one to this one. This is a 2 by 2. This one is also a 2 by 2. Since the sizes are the same, you just add corresponding elements. Here we have 3 and 5. We have 4 and negative 4. We have negative 1 plus 1. And we have 5 plus 4. So we end up with 8, 0, 0, 9. So this is the matrix that we get after we add matrices A and B together. Now an additive inverse means what can I add B to so that I get all of these zeros? Well, that's pretty much just going to be the opposite, right? The additive inverse. The opposite, what do we put in there? We put an add. So the opposite of 5 would be negative 5. The opposite of negative 4 would be 4. The opposite of 1 would be negative 1. And the opposite of 4 would be negative 4. So if you were to add these two together, you get 0. Negative 4 plus 4 is 0. 1 plus negative 1 is 0, etc. So this would be called the additive inverse of B. And I just said that about adding and subtracting, the size has to be the same. So here we're trying to subtract two matrices. This is a 1 by 3, This one is also a 1 by 3. So you can subtract them. Just be really careful whenever you start subtracting. That's 1 minus 1. That's negative 2 minus 2. And that's 4 minus 3. So you end up with 0, negative 4, and 1. Now if you want to multiply a matrix by a scalar, that just means multiply a matrix by some number. It's kind of like just distributing that number to all the elements in the matrix. So this one says to multiply 4 times the matrix C. So it would look like this. So you just multiply every element by 4. 4 times 1 is 4. 4 times negative 2 is negative 8. 4 times 9 is 36. And you're done. Okay, how about this one? We want to add A and B together. Think we can do this one in our heads? Negative 2 plus 1 is negative 1. 3 plus 0 is 3. 4 plus negative 3 is 1. Negative 5 plus 5 is 0. Okay, the last one we're supposed to multiply everything in A by 3, everything in B by a negative 2, or 2, and then subtract them. So it looks something like this. 3 times all of this minus 2 times all of this. So if we multiply this out, we get negative 6, 9, 12, negative 15. Now there's a couple of ways you can handle this. You can distribute a negative, or you can leave the minus there and just distribute the 2. So if you distribute the negative, it's the same thing as doing that, right? So you're going to add whatever you get when you distribute the negative 2. So that's negative 2 times 1, negative 2 times 0, negative 2 times negative 3, and negative 2 times 5. Now we just add corresponding elements. Negative 6 and negative 2 is negative 8. 9 plus 0 is 9. 12 plus 6 is 18. And negative 15 plus negative 10 is negative 25.